In 10-6, you're going to learn about positive and negative numbers. My objective is to introduce addition involving negative integers. Let's do some mental math and reflexes. So, are you better off if you have $3 or you owe $10? You're right, to have $3. Is it better to owe $4 or to owe $9? Good, to own only four. Owe only four. To owe someone $20 or to owe them $100? Very good, to owe them only 20. So which is colder, if you have a negative 3 degrees Celsius or 10 degrees Celsius? Awesome, negative 3. Negative 9 or 19? Negative 9. Negative 7 or negative 11? So think about the money. Did you want to owe 4 or owe 9? So really, if you owe 4, you're a negative 4. If you owe 9, you're a negative 9. So which is colder? Which one would be worse? The negative 11. Now it's just the opposite. Which is greater? To have a negative $10 in your bank account or to have 8? 8. To have 5 in your bank account or a negative 1? 5. $10 or a negative $10? $10. Take a copy of Math Masters page 320 and follow the directions along and we'll answer the questions. Share your transparent mirror if you're with a partner, or I'm sure there's plenty in the classroom. So you need to place your transparent mirror on the dashed line that passes through 0 on the number line. So it's showing here. Here's the dotted line. Excuse me if it's not perfect. Look through the mirror. What do you see? What negative number image do you see? Hopefully you notice that above the 1 was a negative 1, above the 2 was a negative 2, and above the 8 was a negative 8. If you didn't see that, go back and look at it a second time. I want you to learn this, that one way to think about a number line is to imagine the whole numbers reflected across the 0 point. So each of these positive numbers picks up a negative sign as it crosses over to the other side of 0. The opposite of a positive number is a negative number. Conversely, imagine the negative numbers reflected across the 0 point. The sign of each number changes from a negative to positive as it crosses to the other side of 0. The opposite of a negative number is a positive number. When you place the transparent mirror on the line passing through the 0 point on Math Masters page 320, the negative numbers appear reversed across from the corresponding positive numbers. So take a look at that a second time to make sure that you understand what I'm saying here. If not, replay this part. Or step back to the table and I'll explain it to you more thoroughly. So negative numbers and rational numbers. You've used counting numbers 1, 2, 3, and so on for thousands of years. Not you personally, but people. Long ago, people found that counting numbers did not meet all of their needs. They needed numbers for in-between measures, such as 2½ inches, or it took 6 5/6 hours. Fractions were invented to meet these needs. Fractions can also be renamed as decimals and percents, and most of the numbers you have seen are fractions or can be renamed as fractions. So if you look over here, 0 equals 0 over 1, because anything divided by 1 is 0. 12 equals 12 over 1, or 12 divided by 1 is 12. 15.3 equals 153 over 10, because that's the decimals in the tenths position. 3.75 is 375 over 100, because the decimal point has 2 place values after it for hundredths position. 25% equals 25 over 100. However, even fractions did not meet every need. For example, problems such as 5 minus 7 and 2 3/4 minus 5 1/4 have answers that are less than 0, and they cannot be named as fractions. Fractions, by the way, are defined. It can never be less than 0. This led to the invention of negative numbers. Negative numbers are numbers that are less than 0. The numbers negative 1/2 and negative 2.75 and negative 100 are negative numbers. The numbered negative 2 is read negative 2. Negative numbers serve several purposes. To express locations, such as temperatures below 0 on a thermometer and depths below sea level. They show changes such as yard losses in a football game. They extend the number line to the left of the 0. They calculate answers to many subtraction problems. The opposite of every positive number is a negative number, and the opposite of every negative number is a positive number. The number 0 is neither positive nor negative. 0 is also its own opposite. So the diagram at the right shows this relationship. The rational numbers are all the numbers that can be written or renamed as fractions or as negative numbers. So you notice that right here is the 0. So to the right of the 0 is positive 1. The first place to the left of the 0 is negative 1. The second place to the right of 0 is positive 2. And the second place to the left of the 0 is negative 2. And so on. Positive 3 is the third place to the right of the 0. Negative 3 is the third place to the left of the 0. Positive 4 is the fourth place to the right of the 0. Negative 4 is the fourth place to the left of the 0. Just make sure you're understanding that relationship. So, Math Masters, page 321. In this lesson, you're going to pretend that you are accountants for a new business, and you need to figure out the bottom line as you post transactions. Credits are money received for sales or interest earned and other income. As positive additions to the bottom line, meaning you're going to add them. And debits, cost of making goods, salaries, and other expenses, are negative additions to the bottom line. So you're going to subtract them. So you will label credits with the plus sign and debits with the minus sign to keep track of them as positive and negative numbers. So when you look at this, this says there's a new business and you start at 0. So at the end of the transaction, how much money do you have? Well, if you start with 0, your change is 0, you have 0. So now a credit payment of 5 comes in. Okay, so it's a deposit. So how much came in? Well, we started with 0 still from the day before. So now we add the $5 because it was deposited, and now we have $5. The next day we have a credit again of $3. Well, our last end transaction was 5, so that's what we're starting with the next day. We get to add or deposit $3 more, so we have a total of $8. So remember, whatever we end with the day before is what we start with the next day, so we're starting with that 8. Now, we need to add, though, a negative 6. It's a debit. It's an expense. So basically we're saying 8 minus 6, which leaves us with only $2 left. Again, we ended with $2, so the next day starts us with only that $2. Uh-oh, we have another $8 bill, and we have only $2 in our possession. So by the time I pay those $2 off that $8, I am still at a negative $6 that I owe. So I start that negative 6 as my next day, and I need to add another negative 3, meaning that I spent 3 more that I truly didn't have, which is going to leave me at a negative 9. Now that's what I start with the next day. Whew, finally, I got a credit of $5. So I'm going to add $5 back into my account. which leaves me at a -4, which doesn't seem quite as bad. So the next day, I start at that -4. And again, hooray! I add another $6 back in. So I'm starting now to have a positive balance once again of $2. So you need to get out math journals and go to page 283. You're going to be solving problems involving equivalent fractions, decimals, percents, and discounts. Then I need you to go into your math journal, correct those, and do math journal page 284. Again, do them all, then go up and correct them. Come back to the table at any time that you are struggling. And the final thing you're going to do for 10-6, and I'm sorry for saying final thing in your math journal is to do math boxes on page 322. Remember to use your SRB and go back to the pages they suggest first up in the lower, right hand corner. And now that's the end of 10-6.